I'm going to do a second and last example. This one's more complicated, but it's still the same procedure. It's just the actual equation is more complicated and there's more values. So it says the safe load, capital L, of a wooden beam supported at both ends varies jointly. It varies jointly with the width W and the square of the depth D, and inversely as the length little l. A 4-inch by 6-inch beam 12 feet long supports a load of 4,800 pounds safely. What is the safe load of a beam that is 6 inches by 10 inches by 15 feet? Okay, so I drew this little diagram so that you know which one's the depth and which one's the width. With beams, they always put the longer side vertical. And that's because of this, excuse me, sorry for that noise. That's because of this equation. The D gets squared, which means you can hold a greater load if you have the D vertical, okay? And the width is horizontal. Okay, but I drew a picture to make sure that you knew which one's W and which one's D. Okay, so the solution, they gave you the equation. They said capital L, where is it? Varies jointly, sorry, I couldn't find it. Varies jointly with the width, right here. Varies jointly with the width. So it's K, don't forget the K, times W, and the square of the depth D, so that's D squared. And inversely as the length L, so that means L is in the denominator. So that's my basic equation. I have not plugged in any of these numbers. Just write out the letters, okay? And then I'm going to plug in the first set of information, which notice has 4 different numbers. My equation has 1, 2, 3, 4, 5 letters. They gave me all of them except for K, so I'm going to use those to find K. Then rewrite this with the known K in it, and then they give me 3 of these values, plus I'll also have K, and I can solve for the 5th one. Okay, so here we go. 4,800 equals K times 4 times 6 squared over 12. Now you might be thinking, why didn't he change 12 feet to inches? Because it doesn't matter. As long as for both sets of information, my length is in feet, it's fine. If I changed it to inches, my value for K would be different, but the answer I got for the whole problem would be the same. Okay, so it doesn't matter, so I just left it as feet because it's easier to put 12 there than to put 12 times 12, 144 inches. So I solved for K and I got 400. Now I go back up and in my second column I'm going to write the equation starting with L equals, and I'm going to put in the 400 for K. But I don't keep those red numbers that I had from the first set. I just use the letters. So the first set of information was just to find K. Okay, and now I can vary any of the capital L, little l, W, or D, and any 3 of those I can vary it, and I can find the value of the 4th one. Okay, so they gave me this 6 inches by 10 inches by 15 feet, and I'm supposed to try to find the load, capital L, that can hold. So I just plug in those numbers where they go. The little l is the 15, right? W is 6 and D is 10. And then I just multiply all that stuff out, and I get 16,000 pounds. So the safe load of a beam of this dimension, 6 inches by 10 inches by 15 feet, with this particular material is 16,000 pounds. If I have a different material, then my constant K will be different. In fact, I used to work at a lumber yard when I was in high school, and they actually, back when they had a lot of different kinds of wood in lumber yards, They used to have a lot more than they do now. And they would have beams of various sizes of various different kinds of wood. And you'd see written on the side where a particular type of wood was stored, you'd see they actually wrote the constant K there. For each type of wood, it has a specific constant that they use in this equation. So that way they don't have to experiment with it. It's already been done, right? So anyway, that's how that works. That's proportionality, or if you want, as a section is called, that's variation.